Can I say, okay, let's start. Hello, everyone. My name is Shinichi NAKASUKA. So nice to meet you. And I can see also some friends. Nice to meet you again. And tonight, I'd like to talk about a Mission Idea Contest 7. It is a kind of the new type of the Mission Idea Contest. It is featuring the Deep Space Mission Challenge. Okay, let me start. So I have been working on the Mission Idea Contest as the organizer as well as the jury, and it started in 2010. So every time we had a very good mission idea and the satellite design, and every time we enjoyed the evaluating these very interesting idea from the young generations, and every time I think I remember that we have about 60 or 70 submissions, and we evaluated, and about 10 are selected, and they came to the final round, which is organized at the time of the UNISEC-Global meeting. And finally, the first and second, third prize has been decided. So this is winners mission ideas. In the mission idea 1, we features the constellation missions. And a very interesting idea was selected. And in the mission idea 2, we have 2 categories. One is a satellite design contest, and the second one is a business model contest. And also we had a very, very interesting ideas. Mission idea 3, 4, 5, and in the mission idea 6, which was held last year, we had a very interesting new topics. That is the utilization of the ISS. The ice cube is providing a 10 centimeter cubic space inside of the ISS for someone to do some experiment in space. And also as a company, Space BD is providing the ICEP facility also for the experiment on the ISS, but this is outside of the pressurized module. So this is the ICEP. So what you can do on this ICEP, that is a mission idea contest. And the last year, we also had a very interesting idea to utilize inside of ISS and outside of ISS. So now it's time to go to deep space. That is the mission idea contest 7. And the requirement is a proposed deep space science and exploration mission with micro nano satellites. And we would like to provide some realistic constraints, which will be shown later. So please consider this kind of the deep space spacecraft, as well as design of the trajectory to go to the deep space. So let me briefly introduce the importance of satellite design and also the mission idea contest. Maybe, do you know this? It is design or some chart and function. What is the relationship of these two things? So if you have a design chart, maybe you can analyze or simulate, and the function can be obtained. But if you design a satellite, you should do the reversely. So we first, define some functions, what we want to do, what we want to obtain. And then in order to realize that functions, we should design a satellite. Okay, so this also occurs in the diagnosis. So the doctor diagnosis from symptom to causes. So seeing the symptom of the patients, they should analyze, they should estimate the causes of the diseases. Everyday life. So also we have a similar relationship. So we want to obtain a certain effective result. So in order to realize that, we do some planning or scheduling action. So this is also very important. So in this way, we should find a very important engineering skill. That is a backward reasoning, or sometimes it is called the inverse program. Everyday life requires many, many problem solving skills. Life is full of problem solving, and we can tell whether answer exists or not. Sometimes there is no answer. You should answer with knowledge and skills in a various field, not only engineering side, but also the economics, culture, ethics, roles, and many other areas. Frequently, you should solve the problem as a team. And problem solving skills is very important. So you should train yourself in these skills. But these skills can only be trained only if you really want to solve the problem. You should have a very strong motivation to solve the problem. Only in that case, you can train yourself. So the strong motivation is essentially required. Satellite project is a kind of the problem solving. That is a problem solving of mission success. So in this case, again, you should first define the scientific goal and then go back to the mission scenario design and then go back to the orbit and the spacecraft design. So this is a very good training of the inverse problem solving. And it is not academic paper. In the academic paper, at the finally, you can write. So we'd like to do this kind of research in the next paper or something. That is possible. But in order to realize some such system in the space, that is not allowed. Systems should behave correctly in the real world anyway. Okay? And requiring integration of multiple fields, knowledge, and skills, people with various background and expertise. This is a very special features of the space project. So you should require the various field, expertise and various type of the people. And if you don't know, then you should search for someone who knows it. And also, this is an example of open innovation. And the satellite project, maybe if you participate in the project, maybe you experience that, giving you very strong motivation to solve the problem. We want to make a satellite succeed in space. We want to make our satellite work properly in space. That is a very, very strong motivation. So the satellite project itself is a very good training for the problem solving skills. Okay, and also the design contest is very similar. Yeah, we want to win the competition. That gives a very strong. Okay, someone is doing some party. Okay, and then now we'd like to go to the deep space mission. So in the mission 7, mission AEDA contest 7 features the deep space missions. Why? Okay. This is because maybe the technological field of the LEO, low Earth orbit satellite, already almost established. And the, and we consider that the creation of the deep space mission will give young generation more motivations towards something like a frontier spirit. And the deep space missions require more variety of knowledge and skills, which will give additional areas for teaching and learning. Okay, and most importantly, because of the technological development of micro nano satellite, deep space missions are already possible within university capability and small size satellite. So maybe as you know, the NASA JPL is now performing the new initiative, CubeSat initiative, to deliver this kind of 3U or 6U CubeSat into the deep space like Mars, Jupiter, and so on. So this is a kind of the evidence that even this kind of the small satellite can go into the deep space. And let me briefly show our history of the satellite development. We started with the world first CubeSat, and so this is a kind of the education or experiment, and then go to the space science with the Nano Jasmine, our fourth satellite, and the Earth observation has been performed by the Hodoyoshi 134, and the deep space missions have been performed by Procyon, and now we are preparing for the next deep space mission, Icarus. And the technological demonstration or capacity building support project and some entertainment project using a 3U CubeSat size. So in this way, we have been developing many type of the satellite which are, even going into the deep space.
So, Professor NAKASUKA, you have 5 minutes left.
Okay. So in the our first deep space mission is a Procyon. That is a first 50-kilogram class deep space probe, which was developed and launched in 2014. It went into the deep space together with Hayabusa 2, and in a one-year cruise in the deep space, we succeeded in many, engineering and scientific experiments. And now the students are developing the 6U CubeSat Aquarius, which are targeting toward the Earth-Moon Lagrange point 2, that is the other side of the moon. And so deep space exploration mission is now possible with just an 11-kilogram satellite. So this satellite is now planned to be launched by NASA's SLS rocket next year. So the inside of the satellite looks like this. Almost all the component is developed by ourselves or our venture companies. And for the mission ideas contest 7, requirement and constraint. So we don't have specific requirements. So you should create your own mission ideas. That is a scientific goal, and specify the requirements for them. But we should put some realistic constraint, such as a departure, delta V, depend on the mass of the satellite, and onboard communication system. This is very similar to the Prokion and the deep space network for the ground station performance. A certain position estimation accuracy is also assumed. A lifetime is arbitrary, and the launch window should be earlier than 2030. So based on this kind of the constraint, you should also design the orbit like this. This is the design of the orbit for the Aquarius mission, which are targeting toward the Earth-Moon Lagrange point 2. It requires a lot of swing-by missions. Finally, so this kind of the deep space mission requires very different type of the expertise and the learning outside of the LEO missions. For example, design of the trajectory. Most of the deep space mission requires a 3-body or multi-body program. So you should learn about the sphere of influence and patched conics method or swing-by mechanism. Design of the Explorer is also different from the LEO mission, like radiation effect analysis, you should do that, and long-range communication, optical navigation, long lifetime, and autonomy, because communication delay is significant in the deep space mission. And ground station and operation would also be different from a LEO mission. For example, in the LEO mission, usually you have the 4 times of the 10 minutes communication time per day. But in the deep space mission, usually you have the 8 hours consecutive operation time per day. So in this way, many missions are different. Many ground operation would be different from the LEO case. So we are waiting for the innovative and interesting idea of mission and spacecraft design. Please join us. Thank you very much.